times 29. And then we just chuck that into our calculator exactly like that. And we get 420,5. So 420,5 centimeters squared. So that is my pink triangle.
Okay.
Okay. If I wanted the blue area, so when your teacher asked for it, did he want what I've colored in blue, or did he want the area of the full circle?
He wanted both.
Okay. So the full circle, so the area of my full circle, okay, that's going to be pi r squared. So that's going to be pi times 29 squared. So we're going to say pi times 29 squared, which is going to give us 2642,08 centimeters squared. So that's my full circle.
Okay, ma'am.
And then if you wanted just the blue area, you would just take this full circle and minus the pink part, and then you have your blue part.
So, ma'am, how many marks will this be? Because it deserves a lot of marks.
Yeah, it depends on if they've like scaffolded it. So I'd say if they wrote it just as like one big question, probably between 5 and 6.
Okay. Okay.
Okay.
Thank you, ma'am, so much.
You're welcome. Okay, guys, so we've still got a couple of minutes here. If you have questions, please pop your hands up for me. And then I'm happy to answer them. And if we don't have questions in the next couple of minutes, we'll just get going on some revision. Kira, maths paper 1, very exciting, ready to shine here during the stress of exams. Hopefully we can resolve some of your questions or stress today by going over some of this stuff to get you ready for paper 1. Okay, so what I've got here is just a quick summary of all of our different exponent rules. Okay, we're going to chat about them very briefly, and then we're going to look at a whole bunch of different examples. We'll see what we can get through. We'll try and do as many as we can, but please ask questions if there's anything you are confused about. Okay. So the first one, when we are multiplying things and they have the same base. So what I mean by that is those two x's, they are the same. Okay. That means they have the same base because they're both x's. When we're multiplying things that have the same base, all we do is we add those exponents. So what I mean by that is if I had x to the power of 2 times x to the power of 3, that is going to become x to the power of 5. So we're going to take that 2, we're going to add the 3, and we're going to get a 5. Okay. And guys, if at any point you feel confused, you just pop that hand up. Don't feel like you're interrupting me. This is your time to get ready for your exams. So you must ask questions when you need to, okay? Yes, Namaza, how can I help?
Sorry, ma'am, are we doing exponents?
Mm.
Oh, okay, so like, thanks.
I think this is a mic situation because I don't see a mic. So I'm going to,
Yeah,
can you help?
I'm on it.
Yes. Okay. All right. Law 2, we've got division. So if we have something with the same base, again, these x's are the same as each other, then all we're going to do is we're going to take the one exponent and minus the other. And it doesn't matter if the one is bigger than the other. You can have a negative number because we're going to deal with that down here. Okay. So what I mean by that is if I had x to the power of 6 over x to the power, what am I writing? X to the power of 2, I'm going to say 6 minus 2, and I'm going to get 4. Okay, let's write it the other way around. Let's say we had x to the power of 2 over x to the power of 6. We're going to say 2 minus 6, and so we're going to get x to the negative 4. And we wouldn't leave it like that because we don't like leaving exponents in their negative form, but we would deal with it when we talk about negatives. Okay, so that's multiplication and division. Next one, when we have a power to a power. So as soon as you have a power to a power, all you're doing is you are multiplying those exponents. So would there be a letter instead of a number? There could be, Tando. So like if they were wanting to try and test you with something, but that would be considered higher order, if that helps. So if we had x to the power of 4, and that was all to the power of, let's say, 3, we're going to multiply those two numbers, so we're going to get x to the power of 12. Okay. Law 4 is an extension of law 3. So it's just if we have multiple things over here, and it also is going to a power, we're going to multiply all of those by that same power. So if I had x to the power of 2, y to the power of 3, and all of that was to the power of 3, then I'm going to have x to the power of 6, y to the power of 9. So I'm going to do it for everything that's inside that bracket. Okay. Our favorite one, which is the easiest one of all, is that we have anything that is to the power of 0 is equal to 1. Okay, anything. Now, I mean anything. So if I had like negative 2, x to the power of 7, y to the power of 9, and all of that was to the power of 0, that's going to equal 1. Anything to the power of 0 is equal to 1. All right. And then our last rule, which is one of the ones that we learned in grade 9, because we didn't do this one last year, is if we have a negative exponent, that's the same as saying 1 over it as a positive exponent. So if we have, let's say, x to the power of negative 3, that's the same as saying 1 over x to the power of 3. If we had 1 over x to the power of negative 4, that's the same as saying x to the power of 4. So we would be flipping them, essentially, when we're wanting to get something to not be a negative. Okay, so that is a summary of all of our different exponential rules. Does anyone have any questions about what they are currently seeing on the screen? Cool. Let's get into some examples then. Yeah, Kieran, how can I help?
Sorry. So what happens when like for example, x to the power of negative 4 is on the top? What do we do?
So like this one over here.
Yes, ma'am.
That's just, if I wanted to make that positive, that would be 1 over x to the power of 4.
Oh, okay. Thank you, ma'am.
Okay, no problem. Okay, oh, that's another mic issue. Poor you lenders, like on a roll with it. Yes, this is the grade 9 class. Bruce, how can I help?
Hello, ma'am.
Hi.
Ma'am, sorry, may I please just take a screenshot quickly before we move to the
Sure,
next example?
absolutely, no problem.
Thanks.
All good. All right, let's try some of these questions. I'm going to put both up on the board so you can get going. These are obviously as easy as these ones can get. Okay, there's nothing too scandalous about them. We're going to talk about a couple of things. They are, well, there's one specific trap that well, two potential traps, one definite trap. Let's see how you guys go. So I'd like the answer for A and I would like the answer for B. So get going, see how it goes, and then we'll talk about what our two different answers are. And don't worry if you're finding these way too easy and you're like, oh, this is so boring. I promise we're getting onto some spicy ones just now. Yes, Zanele, how can I help? So there should be a notification on your side to unmute. You just need to accept it. Okay, let's have a look at this first one. So the first one is not actually so stressful. Okay, we have, this is when we talk about signs, numbers, and variables, all right? So those of you who remember from the beginning of the year, we talk about SNV. The S stands for signs, the N stands for numbers, and the V stands for variables, okay? What that means is we want to sort of work through those three things when we get to these types of questions. So the first one, we're looking at signs. We have two positives, so it's positive. Numbers, if there was a number, that would be a 1. So 1 times 2 is 2. Then we look at our variables. We've got x to the 3 and x to the 4. We're multiplying them, so we're going to add them together, and we're going to get 2x to the power of 7. That's all we need to do for that one. Okay. For B, I'm not going to go over it just yet because I haven't seen too many answers come in it just yet, but don't fall for the trap that is waiting for you in B. There is a trap in B, and I don't want you to fall for that trap. Oh, hi, it's Nele.
I don't think I know the answer to number B and understand.
I think there might be something happening with your line. It was coming through a little bit broken. It might be easiest to write it in the chat. Oh, I see people falling for my trap in these answers. Kieran, have you fallen for my trap?
Ma'am, hopefully not.
Okay.
So I saw everyone saying, so I got minus 9x to the power of 6.
You've also fallen for my trap. Let's
try
see.
though. Keep trying.
Good try. Yes, exactly.
Yeah.
This is how we learn. Kira, what did you get for B? Oh, Kira, we can't hear you. That was so sad. Yeah, what did you get for B?
I got -3 to the power of 6.
No. Also falling for my trap.
You can do this, my bibs.
These traps
Okay,
are
guys.
here. These traps are here because this is what you'll be seeing in your paper, and I don't want you to panic. Okay.
Yeah.
So I haven't seen the correct answer just yet. I'm going to show you a way that we can work this out to make sure we don't fall for the trap though. Okay. So when we see something like this, and this whole thing is in brackets and it's to the power of 3. This is when we say, when in doubt, write it out. Okay. It takes 10 seconds to write this out, and it is worth your time. So we're going to say -3x squared times -3x squared. And you don't need to keep these in brackets. I'm just putting them in brackets so you can see what to do. Okay, so all we've done is we've written it out 3 times because it's to the power of 3. Then when we do that, we follow through these rules. Okay, so the first thing we look for is signs. We've got a negative times a negative times a negative. That means my answer is going to be negative. Then we do the next step, which is numbers. 3 times 3 is 9. 9 times 3 is 27. Then we look at our variables. For our variables, we've got x squared, and x squared. And so that is going to become x to the power of 6. So if you are feeling like you're not entirely sure what to do, these ones, it's worth your time to just write it out, because as soon as you see it written like that, you're not going to fall for any of the mistakes. Okay. If, however, you're wanting to do it without writing it out that way, what you need to remember is that this cube is like going through to each thing. So it's like saying, what is my negative cubed? And a negative cubed, so that's a negative times 3 times, is going to be a negative. What is 3 cubed? 3 cubed is going to be 27. And then that's going to be x to the power of 6. So you're kind of doing it step by step. So Kieran, this law is actually working with this one over here, so power to a power. But when we write it out the long way, we're turning it into a multiplication law. So we're changing it into something which is a little bit more manageable to deal with. Okay, I'm seeing a couple of hands, so I'm just going to go through these questions. If your hand is up and it's not a question, please, can you just drop it for me so that I don't unmute you unnecessarily? Bang, how can I help?
How did we get? I understand that -3 times -3 is 9 times -3 is 27. When we supposed to square the -3, the entire thing.
So if we're writing it out this long way, what this is meaning is it's saying this whole bracket is being cubed. So that whole bracket is being written out 3 times.
Yes.
So all we're doing here is we're just writing it out 3 times.
What I'm actually asking is that by inside the bracket, -3x, isn't it supposed to be multiplied twice?
No. The only thing that is being squared there is the x. If I had to write that out a long way, it would look like this: -3x times x cubed. So that square has nothing to do with my 3.
Okay, ma'am.
Okay. Okay, yes, how can I help? Hello?
Ma'am,
Yeah.
please change my name.
Yes.
And-
Yolanda, can you change to Otapeng for us, please?
Noted.
Bruce, how can I help?
Hello, ma'am. Ma'am, so if it's -3 x squared, ma'am, and we say to the power 6, can we write it down the same way as you wrote it here, but 6 times and still get the same answer?
-3. Just say that again for me. -3.
Ma'am, like brackets, -3x squared,
And
and then
to
to
the power of
6.
6. Yeah,
Yes.
then you would just write it out 6 times.
And then we just do the same method as SNV.
Same method.
Okay, thank you, ma'am.
Okay. Kira, yeah. Oh, no, we still can't hear you. Try and plug your headphones in and out for us. Aka? Hello? We're doing really well here, guys. Okay, we're going to try and go through a few others, and I think this will start filling in. It just takes time. Just takes time and practice. Okay, this one I don't want you to panic about. This one is oh, hold on. There was someone who asked for a picture of this before I moved on. So if that was you, please take your screenshot now. Yes, Ochipeng, how can I help?
Ma'am, which heading does this topic fall under?
This is
we're working on.
This is algebra, and it's a subheading would be exponents.
Ma'am, oh, exponents, okay.
Okay. Okay, guys, nice and easy. Don't overthink this, but also don't fall for the trap. Kamogelo, you have fallen for my trap. Mateo, you have also fallen for the trap. Nati, well done. Okay, guys, remember that anything to the power of 0 is 1. Okay, but that 3 is not to the power of 0. The only thing that's to the power of 0 is that x. That 3 is definitely not to the power of 0. Okay, and so if I had to write this out, I'd be saying that that's 3 times x to the power of 0, which is 1. That's 1. And so my final answer is just 3. Okay, so this part over here is equal to 1. If it looked like this, if I had in brackets 3x and all of that was to the power of 0, then that would equal 1. But don't worry, we'd rather fall into these traps when you're with me than when you're in your test or exam. That's why we're going over all these questions. I'm specifically putting questions on the board to try and trap you. That's the whole purpose of today. Okay, Otsupeng, how can I help?
Ma'am, I'm unmuted by mistake.
Okay, can you carry on explaining?
Can you?
Kira, how can I help? Is your sound working? No, no, it's not. Cool. Princess, how can I help? Yeah, Princess, also sound issues. I think it might be a mic issue. Try and unplug your headphones and plug them back in again. For the questions that are coming up on the board, you do not need to show this multiplication sign at all. You can just jump straight to your answer of 3. I'm just showing you what that step would look like as to why it's 3 and why it's not 1. So the reason we remove the x is because x to the power of 0 is 1. It is what it is. That's so anything to the power of 0 is equal to 1. The x isn't there when we have something to the power of 0 because it just becomes 1. Okay. What's wrong, Palesa? Just sad face. So for those of you who want to move on, you can give D a try so long. But for those of you who are not understanding this still, okay, this comes back to the rule that anything to the power of 0 is equal to 1. So if I have y to the power of 0, that's equal to 1. If I had 3y in brackets to the power of 0, that's equal to 1. If I had x to the power of 0, that's equal to 1. Okay, but if I have 2x to the power of 0, this x to the power of 0 over here is the same as that. Okay, so that's equal to 1. So that's the same as saying 2 times 1, which is 2. So only the thing that is to the power of 0 is equal to 1. So this over here, that x to the power of 0, that's what's equal to 1. So this is the same as saying 3 times x to the power of 0, which is 1, which would then give us our answer of 3. Yes, so this is simplifying. This is just looking at it as slightly different. Yes, Palesa, I have seen your question. I can't do it all at the same time. I wish I could. I'm just not an octopus. So we're going to first go through this question and then I will go back up to the previous one so you can take a screenshot. Sonke, how can I help?
Hello, ma'am.
Hi.
If the question was 3x to the power of 1, what would the answer be, ma'am?
3x to the power of 1 is just 3x.
Oh, okay. Thank you, ma'am. That's all I need to know.
No problem. Okay, so let's have a look at D for those of you who are working with D over here. Again, we're going to work with it in the 2 different things. So we're going to do signs, numbers, variables. Okay, signs, they're both positive, so we don't need to stress. So now let's look at our numbers. So our numbers, we've got this 3 over here and we've got a 6 at the bottom. If you really struggle with fractions, you can always put it into your calculator and just write it as a fraction, 3 over 6, and push equals, and it will simplify it for you. Okay, what I mean by that is in your fraction button like that, I'm going to put 3 over 6. So that is what it looks like at the moment. And I'm just going to push equals and you will see it's a half. Okay. Alternatively, you can think, well, what number is going to go into 3 and 6? And it's going to be 2. So, well, 3. 3 goes into 3 once and 3 goes into 6 twice. So we're going to have 1 over 2. So we're going to look at our numbers first. Cool. Now we've done our numbers. Now we look at our variables. So we're going to start with each one. We're going to look at our x's. When you get to this point over here, okay, you could follow the rule of saying 2 minus 3. but we're going to have a negative number, which is fine. So I'll show you what to do if we do that. But what's generally easier in these questions is just look where they are bigger. Okay, so x to the power of 3 is bigger than x to the power of 2. If I had to write this out the long way, this is what this would look like. I would have 3 over 6. I'd have 2 x's up there. I would have 4 y's up there. And you're also welcome to write this out in your test like this, if it helps. Okay, I have 3 x's at the bottom, and then I've got 2 y's. So if I was looking at this, that x will cancel with that x, and that x will cancel with that x. And you'll see that you're left with 1x at the bottom. It's really important that you get that position correct. Okay, so if you didn't want to write it out the long way, you can just look at, we've got the x squared at the top and the x cubed at the bottom. Where is it bigger? That's where my answer is going to land up being. And then I'm just saying what's 3 minus 2, and that's 1. So I'm going to have 1x just left there at the bottom. Okay. Then I'm going to look at my y's. I've got y to the power of 4 there and y to the power of 2 there. Where are they bigger? They're bigger at the top. So 4 minus 2 is going to be y squared. And that's where I would leave my answer. So I would say, and you could write it as a half and then y squared over x, but it's really important that your x is at the bottom and it's not at the top, which is a very, very normal mistake for people to make. Okay, let's say you didn't want to do it like that. Let's say you wanted to work with the negatives. Okay, so we would definitely have our 1 over 2. That's not going to change. Then we'd work with negatives. So 2 minus 3 is going to give me negative 1. And 4 minus 2 is going to give me 2. But we're not allowed to leave our answers in a negative form. And so in order for me to make that positive, I would need to move it down to the bottom. And then it would be positive. So those would be all of my different ways of working through this. So we could either write it out the long way, and then that one, those two would cancel. So we'd be left with 2 y's at the top, 1x at the bottom, and the 3, 6. Or we could work with negatives, or we could go straight into simplifying on the left. All 3 of those ways are perfectly fine to do. So just be careful. We can't say 3 minus 6 because these numbers over here, they are not being subtracted, they're being divided. As soon as we have a fraction, that means divide. That means 3 divided by 6. Yes, so if you said 2xy squared, that would be wrong. It needs to look exactly like this. We need to have, well, you don't have to have that 1 there, but you would have to have y squared at the top and 2x at the bottom. Yes, 3xy squared would also be wrong. If it doesn't look exactly like this, or without that 1, it would be wrong. Okay, Bruce, how can I help?
Ma'am, if x squared and x cubed, ma'am, were like flipped, so
Yeah.
if so like it was gonna look different, ma'am, how would our answer be like now?
So it would look almost the same, just one thing would be different. So the 3 and the 6 would still simplify to 1 over 2, and then I would have 1x at the top, and I would have 2 y's at the top.
Oh, okay, ma'am, so everything would stay on the top.
Except for my 2.
Okay.
Okay. How many marks would this type of question be? Between 2 and 3, depending on the type of question. Yeah, and where it is in your exam, what they're trying to test. Kira, 3rd time's the charm. Let's see if the sound is working. No! Still nothing.
But Kira has been communicating with us. Then I'm thinking it could be something that she's using that is different from the last time.
Yeah,
okay, Kira,
I know. It's
just
so
try and look
weird.
at that.
Oshipeng, how can I help? Okay. Okay. Talisa, take your screenshots. Kira, I don't know what's going on. I'm so sorry. Tabang, how can I help?
Ma'am, will you be also re-explaining the what is this? It's the parallel straight lines and stuff like that.
That's a very big question. Straight lines, parallel lines. Are you talking about geometry?
Yeah, geometry. Sorry.
We won't be doing geometry because we spent the last sort of 2 months on geometry in lessons. So we're focusing on all the paper one stuff that we haven't done since like first term.
Okay, ma'am.
Okay. Yeah, Alusha, how can I help?
Ma'am, I wanted to ask if would it ever happen in the test that the numbers will not be equal, like for example that they won't have the same, because here you said 3 goes into 6 once. Would it ever like
So
change?
like if I had like a 2 and a 7, for example.
Yes, ma'am.
That
Yes,
then
ma'am.
it will just, yeah. So they can do that and then it'll just stay as a 2 and a 7. We just wouldn't simplify it.
Okay, ma'am. Thank you, ma'am.
Okay, no problem. Okay, for the question for Zanele, for the others, for those of you who are still wanting to work on this, you can start working on E and F, okay? Zanele, the easiest way, if you're really struggling with exponents, the easiest way to work with exponents is to write it out the long way. So you literally would write 3 and then there's 2 x's. So we're going to write 2 x's and then there are 4 y's, okay? Over 6, and then I've got 3 x's at the bottom and I've got 2 y's at the bottom. Okay, and then from there, you look at what can cancel. So that x can cancel with that x can cancel with that x. And we look at our y's. That y can cancel with that y can cancel with that y. And so we say, okay, well, what do we have left then? We've got 3, we've got these 2 y's over here, okay, over 6, and I've got this 1x over here. And then once you've simplified those variables, then it might be a little bit easier at that point to simplify your numbers and see that the 3 and the 6 could become 1 over 2. So that would be my advice if you're really struggling with exponents. I think that would probably be the easiest thing for you to do. But yeah. I know the brain breaks. And the thing is, it's just that there's so little time for us to go over this revision, and I kind of want us to be able to use as much of it as possible to just revise. So I know everyone loves the brain breaks, but I feel like we should just try and focus with the maths today.
Agreed. Let's continue, my pip. You're getting more out of this before your exam. Is that all right?
Guys, this is for your exams. I want us to try and make sure like we know our exam work as best as possible.
Yeah.
Okay, let's have a look at this one. So now this one looks really horrible. Okay, but there's a trick. As soon as you have any kind of fraction like this, you've got a fraction and it's going to a negative number. All right. So as soon as we have a fraction that has a negative exponent, I'm just going to write that out over here. If we have a fraction and it has a negative exponent, we get to do something quite cool. Okay, so when we have a fraction and it has a negative exponent, we are allowed to flip our fraction and make the exponent positive. Okay, so we're going to make the exponent positive. Okay, so flip that fraction, xy squared over 1, make the exponent positive. What is anything to the power of 1? So like what is 5 to the power of 1, for example? 5, exactly. Okay, x to the power of 1 is x. So in this case, anything to the power of 1 is itself. So that's the same as saying xy squared over 1. What is anything divided by 1? So like what is 10 divided by 1, for example. 10, exactly. Okay, so we can actually just write that as xy squared. And that's our answer. You didn't miss the brain break. We are being very rude and we're leaving Brian out of today's lesson to try and maximize revision time. Namaza, how can I help?
Sorry, ma'am, for E,
Mm,
so you would flip it, right, to make the exponent positive, and then after
Yeah.
that, would you just solve for it like normal?
exactly. So the
Okay.
first thing we want to do is we don't want to deal with that negative power. And
Yes,
then
ma'am.
once that's sorted out, we can just deal with it normally.
Okay,
Okay,
thanks.
sure. Any other questions about E? And then we're going to move on to F. I know it's sad, I know. Okay, so Lolita, the key with these types of questions is as soon as we have a fraction that has a negative exponent, so like here it's got a negative exponent of -1, what we are allowed to do is we are allowed to flip the fraction. So you see how my 1 is over here, now my 1 is at the bottom, okay? So we can flip the fraction, and then my exponent becomes a positive. So that -1 becomes a +1. And as soon as I've done that, I can just simplify as normal. Yeah, so like whenever you have any kind of fraction, so like, for example, if I had, let's say I had x over y to the power of -2, okay? What I'm going to do is I'm going to flip my fraction. So that's going to be y over x to the power of +2. And then I've got this power of 2 up here. So that's going to be y squared over x squared. And that would be my final answer. So whenever you have a negative power with a fraction, all you have to do is flip the fraction and then solve from there. So I won't be able to start this one from the beginning just because our time is drastically running out. But remember, there are the recordings of these lessons and you're welcome to watch it. And sometimes it helps to rewatch it and just pause whenever you're needing the pause. So the only time we use KFC is when we are multiplying or dividing fractions. So we don't need to do that just yet here. We will be doing it a little bit later, but not just yet. Okay. All right. If you've got lots of different options, okay, but I'm going to show you the easiest option for you. When we have a power to a power, what do we do? So what I mean by that is we have a power to a power. What do we do when we have a power to a power? Princess, KFC just stands for keep, flip, change. It's when we're dividing fractions. Power to a power, I times. Okay, I times. What would the exponent be for C? Because right now C doesn't have an exponent. So if I wanted to give C an exponent, what would C's exponent be? 1. Great. Okay. Remember, when there's no exponent, we can always put a 1. Okay, and sometimes it helps us to put it there because then we don't forget when we need to use it. So now all we're going to do is we're going to multiply all of our exponents. Okay, so we're going to say a to the power of -2 times -2. What is -2 times -2? +4. Good. Okay, and just be careful with your signs here. So we're going to have a to the power of +4. Then we're going to look at the next one. So we've got 3 times -2. What is +3 times -2? -6. Good. Okay. And our last one over here, we've got -2 times +1. -2 times +1 is going to be -2. Good. Okay. So that's our first step. That's our first step. Now, we're not allowed to leave our answer with negative exponents. So we have an issue because we've got this b to the -6 and we've got the c to the -2, and we're not allowed to leave them like that. So when we have a negative exponent, what do we do to make it positive? What do we do to make that exponent positive if we have a negative exponent? Think
Let's
about
go,
what
my pips.
we're not going to add. Good, we're going to flip. Okay, so just remember this rule. If I have x to the negative 2, that's the same as saying 1 over x squared. Okay, so what I have over here, if I had to write this as a fraction right now, I can always write anything as a fraction, and it would just be over 1, because remember, anything divided by 1 is itself. And sometimes writing it as a fraction will make it easier for you to see where things have to go. Okay, because those two both have negatives, we need to move them down there so that they are positive signs. So we're going to keep our a to the power of 4 at the top. And then down here at the bottom, we're going to say b to the power of 6, c to the power of 2. And they are going to become positive because they have moved down into our denominator. Then Nele, how can I help? You just need to unmute from your side. So you just need to accept the unmuting request. There we go.
Is there any way of doing this fraction?
So doing this, yes, I can hear you.
Is there any way of doing this fraction?
Yeah, so there's a different way of doing this as a fraction. You could, from here, you would, but I think it would be more complicated. You could write it as a fraction, so say 1 over a to the negative 2 b cubed c, and then that would all be to the power of 2. But I think that would be more complicated. That would be the only other way we could go about that one. Alternatively, you could write this as a fraction from the beginning. So you could say, okay, this a to the negative is negative, so we would have b3c1 over a squared, and all of that is to the negative 2. And then do what we've just done now. So flip your fraction, and then your sign becomes positive, and then multiply that in. You're welcome to do it that way. I just think it would be a little bit more confusing, but those would be our only options. Our final answer is definitely going to deal with fractions. Yeah, so we flip anything that's negative. If it's negative and it's at the top, it needs to go at the bottom. And if it's negative at the bottom, it needs to go up to the top. Those are what our options are. So this is just a different option. This is an or situation. Saban, can you try and sort of identify which part of it you don't understand? Lesejo, how can I help?
Ma'am, why do you say a to the power 2 over b to the power 3, c to the power 1?
So this step that's happening over here.
Yes, ma'am.
So this is what we were talking about in the last question. If we have a fraction and it has a negative exponent, we're allowed to flip the fraction and then the exponent becomes positive. So that's just all we've done there is we flipped our fraction and we made our exponent positive.
But ma'am, there were no fractions, ma'am.
Yes, so this first step over here, we created the fraction because this a to the negative 2 is a negative. And because it's negative, we would move it down so that it would become positive. So we made that fraction.
Okay, ma'am. Thank you, ma'am.
Sure. So there's multiple rules going on over here. We've got negative exponent rules. We've got power to a power. It's a whole bunch. I don't multiply the exponents. No. So see, I'm telling that we can only multiply things that have the same base. So the B and the C, they can't interact with each other. Buttercup, how can I help?
I got kicked out of the call. Sorry, I'm confused. Can I say a to the power of 4 and then b minus 6 and then c to like the b to the negative 6 and c to the negative 2? if I
Yes.
don't like make it a fraction. Okay.
That's so
thank you.
that's this first step over here, but you do have to make it a fraction for your final answer.
Oh, okay. Thank you.
Okay. You only add exponents if you're multiplying things. So like a squared times a to the power of 4, then we add those exponents. Okay, guys, if you want to take a screenshot of this, this is your time because I'm going to move on to the next question. Just remember, those of you who are getting kicked out of the call, I do understand, like there's load shedding, there's lots of network issues, but remember we have this recording, so you can always see it. For the question that came in the chat, yes, we are going to do factorization, but only next week. Okay. All right, so I want to see if we can get something a little bit different. Actually, let's do this one because it deals with like a number of different things. Okay. So what we've got over here is, first of all, we have more than one term that's happening. Okay. We've got this term over here, and then we have that term over there. So we have multiple things that are going on. So let's try and break things up as easily as we can to try and make our life a little bit easier. Okay. Firstly, so if I was seeing a question like this in the exam, our first instinct may be to panic because it's this long line. Okay, but we don't need to panic because there's lots of things we can do to make our life easier. The first thing we can say is this whole bracket over here is to the power of 0. So what is that whole bracket to the power of 0 equal to? That whole bracket, it's equal to 1, okay? And because 1 times anything is itself, we can kind of actually just ignore it. So if I was in an exam or a test, I'd actually just cross that out. And so I don't need to worry about it. It's gone. Okay, because anything times 1 is itself. So we can just pretend it doesn't exist. Okay. Then we're going to look over here. So we're going to look at this part over here. Now, in order for us to not fall for that trap, we're going to write it out twice because it is squared. So I'm going to write in brackets, I'm going to have my negative 2x squared and times negative 2x squared. Okay, that's my first. Then I'm going to look over here at this part. So I've got minus negative 3x and then negative 4x cubed. Okay, cool. So already this looks a lot less scary than when we first saw this question. Now we're going to trust our 3 little letters: signs, numbers, variables. Okay, let's look at these orange ones first. So looking at those orange ones, starting with your S, what would my sign be if I have a negative times a negative? What would my sign be? Bruce, how can I help?
It's going to be a negative.
Oh, a negative times a negative.
Positive, ma'am. Sorry.
It's going to be a positive. Yes, it's going to be a positive. Okay, that's our signs. Then we look at our numbers. We've got 2 times 2, and that's going to give us 4. So we're going to have positive 4. And now we're going to look at our variables. Okay, and in our variables, we've got x squared times x squared. So we're going to add those exponents. We're going to land up with x to the power of 4. Okay, that's our first part. Done. That is 2 marks sitting there. Okay. Then we're going to look at this yellow part over here. For the moment, I'm going to ignore this minus. We're going to come back to that minus sign. Okay, now let's look over here. We're going to do the same thing. Signs. What is a negative times a negative? We just spoke about this. A negative times a negative is going to be a positive. Okay. What is 3 times 4? 12. Okay, don't forget the sneaky 1 on top of that x. X to the power of 1 times x to the power of 3 is going to give us what? X to the power of 1 times x to the power of 3 is going to give us x to the power of? Careful, don't forget that 1. You're falling for my trap. We have to add it. 3 plus 1 is 4. Okay, Then if you see here, this minus is just chilling right next to the bracket. So we can actually just ignore our brackets. And so we are left with 4x to the 4 minus 12x to the 4. Now, they've really set a trap for you, because what are these two things? What are they? They are something very special. They are something very special. Yes, guys, they are like terms. Good. So now they're really testing you, because you're having to change your mindset between multiplying and exponents and adding and subtracting. It's a whole lot of things going on. Okay. When they are like terms, it means that our variables and our exponents are exactly the same, and we are plussing and minusing. Okay. And so then we just need to think of the numbers. We've got 4 here, we're minusing 12. And so we are going to land up with negative 8x to the power of 4. And this would be worth a huge amount of marks. So this part over here would be worth 2 marks to get the positive 4 and the x to the power of 4. This would be 2 marks to get the negative 12 and the x to the power of 4. And then you'd probably get 1 mark there for the negative 8x to the power of 4. There's 5 marks for a question like this, which is a lot. Okay.
Well done, my babes.
Nice
Can
job.